All right. Okay. Everybody look at number 10. Siri doesn't want to help. Okay, did we go over these yesterday? Because none of you remembered how to do them. Did anybody look this up? No. How? How do I do these? And for the origin, you do both. And the x-axis, you turn the y to negative, correct? So if I'm testing the y-axis, I'm going to substitute in a negative y. If I'm going to test the x-axis, I'm going to substitute in a negative y. And if I'm going to do the origin, I'm going to substitute both of them. So what tells me it's even is if it's symmetric with the y-axis, which means I would substitute a negative x. And odd is the origin, so I would substitute a negative x and a negative y. Okay? So if you all do not know how to do those, make sure you do, because there are several of these on the test. Okay, so 12, it's not none. It's actually around the origin. And so if I change, whoops. This is what you get, right? Okay, so I don't know what the cube root of 3 is, but do I know what the cube root of negative 1 is? The cube root of negative 1, because I added the negative underneath, correct? So the cube root of negative 1 times negative 1 is positive 1 times the negative 1, negative 1. So this equals negative 1. So this is what I have. I can take this negative and bring it out, because the cube root of negative 1 is negative 1. So when I divide out the negatives, I end up what I started with, so that's symmetric around the origin. Sometimes, when I'm not worrying about driving up in the mountain. Okay. Any other questions? Okay. Okay, we did these yesterday, correct? Yes? Okay, these you can do. What? Yeah. Okay, I want to look at 31. Okay, so for this one, if I'm going to graph this, I have negative x plus 6. So like we talked about yesterday, you have to factor out the negative 1 before you start factoring here. So that means that this is the square root function. So if I start at 0, 0, the minus 6 shifts 6 to the right. And I can't reflect it over the y-axis, so it's here. And my next point was 1, 1. So if I reflect that over the y-axis and then shift it 6, it's here. So right here is my square root function. And if I write the domain and range of my square root function that I did here, so that I would go from negative infinity to 6, or x is less than or equal to 6, and the range would be 0 above 0. So one of the questions that might be on the test is, what is the domain of the inverse? What is the domain of the inverse? So if I have this, what do I do for the inverse? Do I just switch the x and the y? So the domain and range, we would just switch the x and the y here. All right? And to find the inverse, we change the x and the y and we solve. So I think one of the questions ask about a domain and range, and I think one of the questions ask about an actual function. Like you have to switch the x and the y and solve. Okay? Okay, we're not doing 32. Okay, 34 and 35, these are the ones, is this odd or even? Even, because even is like the parabola, right? So it's even with a positive leading coefficient, correct? And what's this one? Odd. And what's the leading coefficient? This is a positive odd. So it's down and then up. But this is up and then down. So this is a negative leading coefficient. Yes. Okay. 38 and 39, y'all have to factor them, correct? And once you factor them, that's where you get your x's. And your x's make your zeros. And since it's the 2 on the negative 5, that's bounce. And another word for bounce is tangency, right? It's tangent or tangency. And how would I do 39? What's the difference between 38 and 39? This has the 4 terms, right? So this is the factor by grouping, where you say, what did these two have in common, and what did these two have in common? And then you have to factor that. All right? Use the remainder theorem to evaluate. What are we doing when I say use the remainder theorem? The synthetic division, okay? So the synthetic division, and we don't change the sign on the C. We use -2, and it ends up getting written like this, because this is the remainder. But when it says use the factor theorem, that's the one. I have x minus 1 here, so that -1 has to become positive. Okay? So when it's written with the parentheses, you have to change the sign. When it's written without the parentheses, you leave it the same. Okay? So it is a factor if the remainder is what? 0. All right? Okay, so 44 and 45, that's the one where it says list the possibles. And so that's where you do the P over the Q, and the P is the last one, and the Q is the first one. And you list out all the factors, and then all the factors on the bottom. And so this one's going to be easy, because once you list them, for instance, is 12/5 a factor? How do you know? What's not there? Well, I have 12, but there's no 5, right? So you're going to be able to find the one that isn't here. There's going to be 4 choices, and you just have to look and see which one isn't there. Okay? So this one, the rule of signs, this is the one where you have to, first of all, how many sign changes do I have here? None. So I don't have any positive roots. And then you substitute in the negative x. And when I substitute in the negative x, I get 5 sign changes. And we count down by 2s, right? 5, 3, and 1. So the question might say, how many positive or how many negative factor choices? Yes? Because what is negative x to the fourth? It's positive. So I only change the signs on the odd exponents. Because the even exponents stay positive. Or the sign doesn't change. Okay, we didn't do these. Okay, so looking at 53, when it says to write the answer, so I have x minus 4. Wait, it's x plus 4. Yeah. So if it's minus 4, it's plus 4 there, sorry. And then the plus becomes a minus, and the minus becomes a plus, right? And then we're going to multiply. So it's easiest to start here. And if I take x times x, that gives me the x squared. And what happens to the middle terms, friends? They drop out, right? I get one positive and one negative. So what's 3 times 3? 9. The square root of 2 times the square root of 2? 2. So 9 times 2 gives me 18. And then I can multiply this out. So when it's written like this for the graphing, so you're not going to have to graph, right? But you're going to have to be able to tell things about the graph. So on this one, what I start with, I'm going to divide out a negative 2. So if I do that, is there a hole here? Did any of the terms cancel? No terms canceled, no hole. So what is the asymptote here? Where do I get the asymptote? The bottom, right? So I get an asymptote at x equals 1. What do I get from the top? The x-intercept. That was close. X-intercept on top, the asymptote on bottom. Where do I get the horizontal asymptote? That's where you get the y-asymptote. I mean the y-intercept. So look, vertical asymptote, x-intercept, f of 0 is your y-intercept. Then you look at the exponents on the x. They're tied. If they're tied, the horizontal asymptote is the leading coefficient. If you don't remember that, you should study that. How do I get a slant asymptote, by the way? If the top is 1 bigger than the bottom, and then what do? Use synthetic divide. Oh, Lord.